So let's start off with Sn2 reactions. Now, to do Sn2 reactions, we have to look at a few factors. So in our substrate over here, the most important factor for our substrate is usually the steric hindrance. So the steric hindrance, what it is, essentially how many carbons we have connected to the main carbon. Now the main carbon is the one connected to the leaving group right here. So let me just label this properly. So we have our leaving group right here, and then we have our main carbon, and we see how many carbons it has. Now, what types of carbons are allowed for Sn2 reactions? Usually methyl carbons, so ones with 0 carbon bonds, primary carbons with 1 carbon bond, like in this situation, and secondary carbons. Those are usually the carbons that will allow Sn2 reactions. Anything more sterically hindered than that, so for example, tertiary, will not be possible for Sn2 reactions. Usually you'll have some sort of other mechanism like Sn1 and E1 and E2. So those are other types of reactions that we're going to speak about later. So that's the type of steric hindrance that we are allowed for Sn2. Now the less sterically hindered, the faster obviously, and the more likely we'll go through Sn2 reactions. For leaving groups, we want stable leaving groups. So stable leaving groups are, for example, chlorine, bromine, iodine, usually the halogens that you will see in most situations. Now, as for our nucleophile, there are going to be a couple things that we will be looking at. In our nucleophile, the main thing we will be looking at is the strength of the nucleophile. So this has to do with how negatively charged it is. So is it negatively charged? That's the first question we ask. And the second question is, if it's not negatively charged, is it still a good nucleophile? So there are some good nucleophiles that are negatively charged. For example, SH. If you have CH3SH, that's still a good nucleophile, even though it's not negatively charged. So that's one of the things we are looking at for a nucleophile. Now, what are some optional things we want to look at that usually will affect how this happens? Now, if we look at our neighbor for both the substrate and the nucleophile, those can actually affect how this reaction happens. If we have a tertiary neighbor, so this situation is not a tertiary neighbor, it's a primary. But if we have a tertiary neighbor, this can affect how it happens. And same thing happens over here. If we have a quaternary neighbor over here, this can also affect how this nucleophile works. So those are the four things we're going to look at: the neighbor, our main carbon, the steric hindrance, our leaving group, and our nucleophile strength. So if you're wondering what the answer is for this situation right here, if you have this substrate right here, react it with our negatively charged sulfur, what will end up happening is that this sulfur essentially attacks the carbon, the main carbon, from the back, and the iodine leaves right away. It happens in a single spot. It happens right away. It's called concerted reaction. It happens all at once. And essentially, your final product ends up looking like this, with the sulfur now being attached, as well as its carbon group right here. Don't forget about that. And then the iodine is just sitting aside in the solvent. So that is your final product. And this is what you would write in as an answer for a test question.